All right, so we are moving on to 6.3, which is called parametric equations. Parametric equations actually introduce a third variable. And in your calculator, it's a capital T. Most of the time in the book, it uses a lowercase t. And by introducing this letter T, it gives us the option to graph sines and curves. So do you remember last year how sometimes you grabbed your graphing calculator and it had that letter T in there? That's exactly it. That's what we're talking about, is when we graph with the third variable T. All right, so I want to kind of give you an idea how this looks. We're actually going to have two equations, both of them containing T. One will be equal to X, and one's going to be equal to Y. So for example, I have X equals T squared minus 2, and Y equals 3T. So we can actually graph this idea. You know, usually we do a table and we have X and Y. But guess what? We get to actually add a third column. So we're going to have T, X, and Y. For our T's, we're going to use the -2, -1, 0, 1, and 2. To find our X values, we're going to take these T's and plug them into the X equation. So if I plug in -2 in here, I get 4 minus 2 is 2. If I plug -1 in, I get 1 minus 2 is -1. I plug 0 in, I get -2. I plug 1 in, I get -1. I plug 2 in, I get 2. Now to get my Y values, I'm going to plug -2 in for my T, so I get -6. Plug -1 in, I get -3. Plug 0 in, I get 0. 1 in, I get 3, and +6. So although we're plugging in T, what we're going to do is graph our X and Y. I'm going to kind of sketch my little graph over here to give you an idea. Plotting 2, -6. Here's this point. -1. Helps if I plot it in the right spot. All right, so 2, -6. This right here is -1. Oh, yeah, -1, -3. So -1, -3, right there. I have -2, 0. I have -1, +3. So here. And I have 2, 6. So 4, 5, 6 up here. You'll notice I actually have this curve, which is a parabola, but now it's on its, that's not a very good drawing. Now it's on its side, so it's curved sideways. Whereas before, when we graphed, if we did a Y equals, we couldn't do anything in our graphing calculator that wasn't a function. So this gives us that opportunity to graph on the side or do additional curves that aren't functions or wouldn't pass the vertical line test, like circles and ovals and all different things. All right, so with that idea in mind, example number 1 today is going to be the first 2 problems you have in your homework, which are 5 and 6. It's just going to ask you to complete the table. And plot the point. So let's say I have X equals T squared plus 4 and Y equals 2T minus 1. The tables in our book, of course, are sideways. They're horizontal. They put T on top, X, and then Y. And again, we're going to use -2, -1, 0, 1, and 2. I start by plugging in my -2. -2 squared is 4 plus 4 is 8. Plug -1 in. 1 squared is 1 plus 4 is 5. Plug 0 in, we get 4. Plug 1 in, we get 5. And plug 2 in, we get 8. Our Y values. Plugging -2 in. 2 times -2 is -4. Minus 1 is -5. Plug -1 in. We get -2 minus 1 is -3. Plugging in 0, we get -1. Plugging in 1, we get 2 minus 1 is +1. And then plugging in 2, we get +3. So we're going to plot these points. So 8, -5. 5, -3. 4, -1. 5, 1. And 8, +3. So you see this is another sideways curve. Let's see if I can draw it better this way. There we go. All right. That's all you have to do for the first two problems. It's just asking you to use this T to find the points to put on a graph. Any questions? All right. And let's go to the next part. The next part is eliminating that T. So what if you're given, and we're going to say eliminate the parameter, because that's what that T is referred to, is the parameter. All right. So you're given these two equations, your x and y, and they have t's in them. We need to get rid of that and put it back to our normal equation. So, one, you're going to solve for one of the equations for t. Solve at least one, we'll say it that way. At least one equation for t. And two, you're going to sub t into the other one. Equation 2. And then 3, you're just going to solve for y. Still some algebra going on today. Solve for y. So let's say the two equations I've given is, I don't know, x equals 1 plus 3t. And how about y equals 4 minus t? We're going to begin by solving for t so that I can get rid of it. If I have x equals 1 plus 3t, I subtract 1 over, x minus 1 equals 3t, and divide both sides by 3. So we get t equals, now I'm going to split this up because I think it'll be easier when we plug it into our other equation. So I have x over 3 minus 1 over 3. Now I'm going to take this and plug it into my other equation where t is. So I have y equals 4 minus x over 3 minus 1 over 3. So y equals, of course, I have to distribute. And then we're going to collect like terms. So we actually get y equals a negative x over 3. And combining like terms, that would be plus 13 over 3. So we actually find out that the equation we have here is a line, or it's linear. All right, where the last couple, or the example I did, that was quadratic, right? It was a parabola. It was on the side, but it was a parabola. All right, so example number 2 then. This is actually what you are doing for numbers 11 through 21. The directions say to eliminate the parameter, so get rid of t, and identify the parametric curve. So it just wants to know what the equation is actually representing. Is it a line? Is it a parabola? Is it a cubic function? Is it a circle? What is it? So let's say I have x equals 5 minus 3t and y equals 2 plus t. So I'm going to, because I'm going to solve for y, I don't want to get rid of that one. I am going to get t by itself over here. I'm going to subtract 5. X minus 5 equals negative 3t. Divide both sides by negative 3. We get our t is going to equal negative 1 over 3x, right? And then plus 5 over 3. Now we're going to take this and plug it in for t over here. So I have y equals 2 plus negative 1/3 x, or x over 3, whichever way you want to write it, plus 5 over 3. And then I'm going to collect like terms. So I get y equals negative 1 over 3x. 2 plus 5/3. 2 is the same as 6/3. So it's actually plus 11/3. And again, x is only to the first power, so this is linear. Try another one. I kind of keep this under the same example though, so I'm just going to draw a little line here. Let's say that x equals t and y equals t squared minus 3. Well, if you come across a problem like this, x is already set equal to t. So the only thing you have to do on these problems is to take this x and plug it in where t is over here. So you just get y equals x squared minus 3. And then what kind of function is this? It's a quadratic, right? Or you can say a parabola if you prefer. Either one's good. All right, how about one more? The same section. Let's say I have x equals t squared, and then I have y equals t minus 5. But in your book, there's a couple of them that put the word hint, a little colon after it. This says to solve for x. All right, there's 2 of them, I think, in your homework today that say that after it. So that means instead of solving for y, I want you to solve for x. So we're going to solve this one for t this time. I'm going to add 5 over. So y plus 5 equals t. I'm going to take this y plus 5 and plug it in over here. That means I get x equals y plus 5 squared. You can actually leave it in this form if you want. If you want to multiply it out using the box, you can do that too, but it's fine in this form. So this is also, because it's squared, this is a quadratic. Now, because this is a quadratic, but it's an x equals, this is a quadratic on its side. You don't have to put that part, but I'm just letting you know that that's the difference between the two. All right, any questions solving there? Those seem pretty easy, you guys? Okay. All right, well, let me move on then. So next part, what if? Don't you love it when I started off with what if? What if the parametric equation has trig involved? When trig is involved, there's a little bit of a trick. Excuse me. So here are the steps I want you to think about. Actually, let me give you an example of what I mean. Maybe your x says 4 cosine t, right? There's our trig. And your y equation says 4 sine t. And we're trying to get rid of that t. This is what we're going to do. So I'm going to come over here. I'm going to say, 1, I need you to square both sides. So when I say both sides, that's both sides of both equations. So this becomes x squared. This becomes 16 cosine squared. This one is y squared. 16 sine squared. Step 2. I'm going to ask you to add the equations together. Because we're going to add the left sides together and we're going to add the right sides together, It's actually a one-to-one function, so that's why it works. So I'm going to add my left sides together. So I say x squared plus y squared equals, now I'm going to add my right sides together, 16 cosine squared t plus sine squared t. Oops, 16. I lost my 16, sorry. 16 sine squared t. Step 3. On the right-hand side, you see there's a 16 in front of both of those. At this point, I want you to undistribute the like coefficient. All right, so this side's going to stay the same. X squared plus y squared equals 16 cosine squared t plus sine squared t. Now, you guys are going, oh, I know what that is in the parentheses, right? So here I want you to simplify that parentheses. Cosine squared plus sine squared equals 1. So x squared plus y squared equals 16 times 1, right? Or just 16. So this is actually a circle with, in this case, center at 0, 0, and a radius equal to 4. All right, so we're going to have a couple of these. So here's my example number 3. This is numbers 23 through 25. And again, we're eliminating the parameter. And let's say I have x equals 3 cosine t and y equals 3 sine t. All right. So first thing we do is we square both sides. So you get x squared equals 9 cosine squared t. Over here, we have y squared equals 9 sine squared t. Now we add our left together and we add our right together. So we have x squared plus y squared equals 9 cosine squared t plus 9 sine squared t. Then we undistribute the 9. X squared plus y squared equals 9 times cosine squared t plus sine squared t, which again we know is 1. So we just end up with x squared plus y squared equals 9, which again is a circle. All right, I only got a little bit more to go, you guys. Hang in there for just a few more minutes, all right? So last thing I need to talk about is what if we got to go the other direction? So the last couple of things, we had a t in it, and we were putting it back to our normal. The next couple questions, we're going to take it from our normal and put in a t. And they kind of follow a formula. So let's do this. When you are finding a parametric from point, it's going to follow the two equations. X equals x1 plus at, and y equals y1 plus bt. All right? So a couple of things I want you to know is we are actually going to assume that t is going to equal 1. We want to know what it is when t equals 1. And that you're going to be given 2 points. So let's say the first point is negative 2, 3. And the second point is 3, 6. So this is actually our x1, y1. And this is actually our x and y. Right? We can make these x2 and y2, same thing, right? So what we're going to do is we're going to start by plugging it in here and solving for a. So I have 3 equals my x1, which is negative 2, plus a times 1, or a. Excuse me, guys, sorry. Adding 2 over, I find out that a equals 5, right? Let's do the second one. I have y, which is 6, equals my y1, which is 3, plus b times 1, or b. So that means my b equals 3. I'm going to take this and this equation and put them together. I'm going to end up with x equals x1, which we said was negative 2, plus a, which is 5, times t. Y equals my y1, which is 3, plus my b, which is 3, times t. This is going to be my final answer that involves my parametric. So, example number 4. This is numbers 27 through 29. Directions are going to ask you to find the parametric. Now, I want to tell you guys that there is more than one correct parametric equation that gives you the same thing. So sometimes the back of the book uses the points in the other direction, which is fine. Just depends. So in this first one, we're finding the parametric in technically the direction of the curve. And let's say we have the point negative 3, and 5, 1. All right. So again, this is my x1, y1, and this is my x and y. So my x equation, I have 5 equals x1 negative 3 plus a. This is a times 1. Adding that over, I get a equals 8. Doing my y equation, I have y equals my y1 plus b. Adding this over, b equals 4. So my equations are x equals x1 plus at, and y equals y1 plus bt. All right, one more thing to talk about. Number 31. Number 31. Example number 5. Number 31 is a little bit different because it's not a line. We know these are lines. It's a line connected between 2 points. In number 31, it actually tells you that it's a circle. It tells you have a circle with center at 4, 2, and a radius equal to 5. So remember when we did example 3, the center was at 0, 0, and we had a radius, right? So the trig functions sneak in there. So the way they work when it's a circle and you're putting it the other direction, you're going to have your x equals x1, which is this is x1, plus r cosine t, and you have y equals y1 plus r sine t. So plugging these in, and that's literally all you're doing is plugging them in. We get x equals x1, which is 4, plus our radius is 5, cosine t. Here we get y equals our y value, which is 2, plus 5 sine t. And that's it. That's, again, your parametrics that represent that circle. Does anybody have any questions today? Your assignment is page 482. And the one question goes to 483. There's just one question. And we are doing numbers 5 and 6. And then number 11 through 31 odd. Okay? And I don't know if I posted number 31. I took a picture of this and put everything in, except for problem number 31. I didn't realize I went to the next page. So number 31 is a circle with center at 5'2", and a radius of 3. So you're just writing those two equations for that, for the last one. Any questions? All right, that's all I have for today. Again, those of you that haven't finished your quizzes review, that's 10 points. My idea is that I'm trying to help some of you by the end of the marking period, maybe sneak your grade up a little bit more if you need to. All right, so that quizzes review was 10 points. All right, so make sure you get that done. All right, if you have any questions, I'm going to hang out for a little bit. If not, you guys have a great weekend. Take care of yourselves. Be safe. All right, and I'm only an email away if you need anything. Bye. Bye. Thank you. Bye.